In this notes walkthrough, we're going to review how to find square roots of numbers, approximate a square root between two integers, order real numbers, and classify real numbers. Square roots are one of two equal factors of a number. Or you can think of it as what number times itself would give you x. And the symbol for square root is that right there. The other thing that's significant about square roots is that all numbers have two square roots actually. So for example, the square root of 4, most people know is 2, because 2 times 2 is 4. But also, if you had a negative 2 and multiplied it by itself, you'd also get 4, because a negative times a negative is positive. So all numbers actually have two square roots. They have a positive and a negative, and you'll need to know which one you're being asked for. So in this first example, because the negative sign's out front, you're being asked to provide the negative square root of 9. So you start by finding the square root of 9, and then you just make it negative. So negative 3. With nothing out front, you're just being asked for the positive square root. So in this case, all you need to provide is 5. And this symbol out front is the plus or minus symbol, or positive negative symbol. So in this case, you're being asked to provide both. So you're giving the positive and the negative square root of 64, which is positive and negative 8. So here you're being asked for the negative square root of 81, so negative 9, both square roots of 100, so positive negative 10, and the square root of 121, which is 11. Here you're being asked to find the negative square root of 400, so we know obviously the answer is going to be negative. Then if you look at the square root of 4, that's 2. Now I need to multiply this number by itself and get 400, which has 2 zeros. So something times itself that would have 2 zeros in the end would need 1 zero to start. So just kind of off to the side, 20 times 20, you would do 2 times 2 is 4, and then add your 2 zeros. Here, you're only finding the positive answer. So you start by finding the square root of 16, which is 4. And this number times itself would need to give you 1, 2, 3, 4 zeros. Therefore, I would need 2 zeros, so 400. And then the square root of 4900 would be 70. So your trick on problems like these is to cut the number of zeros in half. Obviously that would only work if the number of zeros is even, and eventually we'd learn how to do it if that weren't the case, and also the main part of the number needs to be a perfect square. Down here it's a little bit different, so you start by doing the square root of 81, which is 9. And I need to multiply this number by itself and get 4 decimal places. So if I want to get something times itself and get 4 decimal places, that would mean I need 2 decimal places. And you can see that because 0.09 times 0.09, since they each have 2, the total would be 4. And so in this example, obviously it's going to have the square root of 121 is 11. The number inside has 6 decimal places, so that means this number needs 3 decimal places, so 0.011. When you see a problem like this that's solving, you're being asked to provide all values for x, or provide all x values. So the first number that x could be, that if you square it to get 144, would be 12. But then another number exists as well. It could also be negative 12. You could write your answer like this, or you could write your answer like this. Remember that the inverse operation to squaring is square rooting, so that's really what you're doing to both sides. It's just that you need to make sure you give both the positive and negative answers, since x could be either 12 or negative 12 in this case. Give the next two a try, pause the video, press play when you're ready to check your answer. So in this case, x could be 8 or negative 8, and here x could be 1 or negative 1. So to approximate square roots, you first start by placing 32 between the two numbers that you know the square roots of, the two closest, one above and one below. So in this case, 32 falls between 25 and 26, 25 and 36. But we're square rooting 32, so we square root all of them. So the square root of 32 would fall between 5 and 6. If you then had to pick which one it was closer to, it would be closer to 6, because 32 is only 4 away from 36, and the square root is 6. Pause the video, try these 3, press play when you're ready to check your answers. So since 103 falls between 100 and 121, the square root of 103 would be between those square roots, which are 10 and 11. 48 falls between 36 and 49, so the square root of 48 would fall between those square roots, which are 6 and 7. Since it's negative, you just make them both negative in the end, and if you want to be fancy, on a number line you'd see them written in this order, because negative 7 would be farther left and negative 6 would be farther right. But I would take either answer. The square root of 350 falls between 324 and 361. The square root of 324 is 18, the square root of 361 is 19. They're both negative since we're asking for the negative square root, and again, to be fancy, negative 18 and negative 19 and negative 18 would be the order you'd see that on a number line. So it tells you that the folding table, which is a square, has an area of 945. So we have area equals side squared, 945 equals side squared, so we're basically estimating the square root of 945, which falls between the square root of 900 and the square root of 961. The square root of 900 is 30, and the square root of 961 is 31. But since it asks us to approximate to the nearest inch, we pick the one that it's closer to, which is 31, because 45 is only 16 away from 961, whereas 945 is 45 away from 900. Pause the video, give this one a try, press play when you're ready to check your answers. So the square root of 320 falls between the square root of 289 and 324, which are 17 and 18, but it would be far closer to 18. Down here, we're going to evaluate for the given value of x. So the first thing we're going to do, like always, is substitute. So negative 3 times the square root of 64 plus 36. In PEMDAS, remember multiplication and division go left to right. Addition and subtraction go left to right. That's because they're inverse operations. So are exponents and square roots. So square roots, if you have them, would fall in the same spot as exponents. So I don't have any parentheses. So now I'm looking for exponents or square roots, which I have the square root of 64, which is 8. So it says negative 3 times 8 plus 64, which would be negative 24 plus 36, which is positive 12. And then over here, if I substitute in the square root of 36, so I'd have 54 minus 8 times 6. Remember multiplication before subtraction, final answer of 6. So the symbol right here is our square root. By the way, it could also be written like this. You don't really see it a lot, but you could see the 2 out, which is asking for the number times itself. That's called the square root. So this one is the number times itself 3 times, and its name is the cube root. So for this first example, we're asked for the cube root of 8. So what number times itself 3 times will give you 8? That would be a final answer of 2. And you could prove it by doing 2 times 2 is 4, times 2 is 8. Try the next two. Try to find the cube root of 27 and the cube root of 64. Pause the video, press play when you're ready to check your answers. So the cube root of 27 would be 3, because 3 times 3 is 9, and then 9 times 3 is 27. So 3 times itself 3 times would be 27. And the cube root of 64 would be 4, because 4 times 4 is 16, times 4 is 64. So an irrational number. So starts with the prefix IR, which means not. So literally this word would mean not rational, which means we need to know what a rational number is. And a rational number, we know, means that it can be written as a fraction. So therefore, not fractionable kind of mean can't be a fraction. Now there's a whole bunch of numbers we already know that can be fractions, like whole numbers and integers can be fractions just by putting them over 1. Like 3, which is a whole number, can go over 1. Negative 2 can go over 1. Fractions are already fractions, and decimals, as long as they end or repeat, can be fractions. So irrational numbers are really decimals that never end and never repeat. They can't do either of them. And the most famous one is pi. Pi is a never-ending, never-repeating decimal. Therefore, it's irrational. Other numbers that will always be never-ending, never-repeating decimals would be square roots of any non-perfect square. So like, we know the square root of 4 is 2. We know the square root of 9 is 3. We know the square root of 16 is 4. Any number that's not on that list, so like the square root of 5. I don't know the square root of 5, so it would be irrational. Or the square root of 10. I don't know the square root of 10. Nothing times itself would be 10. Or the square root of even 24. So if there's a number inside a square root that you don't know the square root of kind of instantaneously, those would all be irrational numbers. So for example, the square root of 24, I don't know it, it is irrational. As soon as it's irrational, it can't be rational, and then it can't be an integer, and it can't be whole. The square root of 100, well, I know the square root of 100, that's 10. And 10's a whole number, which means it's also an integer, and it's also rational. And if something's rational, it can't be irrational. Complete the rest of this chart, pause the video, press play when you're ready to check your answers. Remember to use all names that apply. So the negative square root of 81 is negative 9. Negative square root of 25 is negative 5. So because both of those are negative, it can't be whole. But they are integer and they are rational. And if something's rational, it can't be irrational. Square root of 361, it's actually 19, which would make it rational, integer, and whole, not irrational. And the square root of 30, we don't know the square root of 30, so it's irrational, which makes it automatically not everything else. So in order to order the following numbers from least to greatest, I'm first going to look at them as two different sets of numbers. I'm going to look at them as negative and positive. And I know that negative numbers are always smaller than positive numbers, so I'm just going to start with those. So I'm going to start with the negative square root of 5 and negative 2.5. And I'm going to picture this on a number line. So let's say this is negative 2 and this is negative 3. I know that negative 2.5 is exactly in the middle. And then if I estimate the negative square root of 5, I know that it falls between negative square root of 4 and negative square root of 9, which means it also falls somewhere between negative 2 and negative 3. But since 5 is closer to 4, and it's going to be somewhere in here, I know that the square root of 5 would be closer to the negative square root of 4, which is negative 2. So 2.5 was right in the middle, but the negative square root of 5 would be closer on this side. So I don't know quite where it would be, but I know it would be somewhere in here. No matter what, negative 2.5 would be farther left. For my final answer, which I'm going to start over here, I have negative 2.5, negative square root of 5. Now I can start to figure out my other numbers. So now I'm going to look at my positives. So I have 4/3, which I know is 1 1/3. Square root of 9, which is 3, and the square root of 13. Now the square root of 13 has to be bigger than the square root of 9, and 1 1/3 is clearly less than 3, which is the square root of 9. So the remaining part of this would be 4/3, square root of 9, square root of 13. That's my final answer. Give the next two a try, pause the video, press play when you're ready to check your answers. So for this first one up here, I know that I'm going to have two negatives I need to compare. So here's negative 3, and then the negative square root of 10 falls somewhere between negative 3 and negative 4, so it's going to be to the left of this one. So I know it's going to go negative 10, negative square root of 10, negative 3. Square root of 16 I know is 4. Square root of 12 has got to be less than the square root of 16, and 19/5 is 4 4/5, so that's got to be bigger than 4. So that's your final answer to that one. This one over here, I have two negatives to compare. There should have been a comma here, by the way. So negative 9/2 I know is negative 4.5. So that falls exactly between negative 4 and negative 5, right in the middle. Negative square root of 20 also falls between negative 4 and negative 5. But 20 is closer to 16, so it's closer to negative 4. So here's negative 9.5, and negative square root of 20 is closer to negative 4 than negative 5. So that means it would go negative 9/2, negative square root of 20, and you have 0. Square root of 7 is between 2 and 3, which no matter what is less than 4.1, and then 5.2.